Let's talk about right triangle trigonometry with similar triangles. Now what I'd like to do first is come over here and just do a little reminder of what a similar triangle is. So similar triangle, let's say I draw this little guy, and then I draw this little guy. Oh, I should say big guy. These two triangles are similar if all the angles are the same measurement. So this angle is the same measurement as that angle. This angle is the same measurement as that angle. And this angle is the same measurement as that angle. If all the angles have the same measurements, we call them similar triangles. Another way to think of similar triangles is it's just a triangle that has been scaled up or scaled down. So I take this triangle, I multiply all the sides by a number, and that gives me the side lengths of this triangle. I just take all of these side lengths and scale them up. Or you could go backwards. You take this triangle, multiply all the side lengths by a fraction to scale it down to this triangle. That's what similar triangles are. They've just been scaled. They're zoomed in and out, essentially. But the angles are the same. So let's start right here by verifying that this triangle is actually similar to this triangle. Now we can't really rely on the angles because we don't know what the angles are. I know that these two are both 90, which is a good start, but I can't prove that this angle is the same as this one and this angle is the same as that one. So instead, I use the scaling up property. If you compare the sides to each other, so 3 to 9, 4 to 12, and 5 to 15, you'll notice that all the sides have been scaled up by 3. We take these sides times them by 3, and that gives us these sides. So how do I know that these are similar triangles? I say these are similar because it has been scaled up by 3. That shows me that these two triangles are similar. Now that I know that they're similar, let's go through and practice our sine, cosine, tangent again. Now, this time I actually have a mistake here. You're supposed to focus on angle beta. That's the angle I want you to focus on. So I want sine of beta, cosine of beta, tangent of beta, cosecant of beta, secant of beta, and cotangent of beta. And get fractions. So what I would like you to do is I want you to practice SOHCAHTOA this time. So pause the video, label the sides of this triangle HONA correctly, and then use your SOHCAHTOA to fill in these fractions. Don't forget to simplify the fractions if you can, and then flip the fractions to find these ones. So pause the video, practice all that, and then come back to check your work. So, what did you notice? Hopefully you noticed that these fractions all simplified to be exactly the same fractions as we had up above. Now this is a really important idea. This means that similar triangles all have the same trig ratios. So basically, if a triangle has the same angle measurements, it doesn't matter how big or small the triangle is, the trig ratios will stay the same. And this brings us to an important idea called our special right triangles. You may have heard of these in the past. We have 45-45-90 and 30-60-90. The reason we study these triangles is because all triangles that have the angles 45-45-90 will have the same trig ratios because they're all similar. Same thing with 30-60-90. So we talk about these special right triangles because they come up a lot. They'll come up again in the unit circle, and we'll use them a lot this entire semester. But the nice thing is, no matter what the side lengths are, as long as the angle measures are 45, 45, 90 or 30, 60, 90, they will have the same trig ratio answers, the same fractions for their answers. So what we're going to do for the rest of this lesson is explore these special right triangles. In the next video, we'll focus on 45, 45, 90 and find the patterns in this triangle, knowing that these patterns work for every 45, 45, 90 triangle, no matter how big or small it is.